Hello everyone, this is the video on chapter 11. It's going to be talking a little bit more about experiments, how things can go wrong for the most part, and how we can know if things are going wrong. So what we're going to be talking about specifically are threats to internal validity, which means threats that make it so we don't really know if the independent variable really caused the difference between groups. We're also going to talk about interrogating null effects. So that is, what if the independent variable does not make a difference? What if there's no differences? What do we do? So when it comes to threats to internal validity, what we're going to chat about is first the really bad experiment. This is just a design that's used a lot, but can't really answer the questions that we want them to. Next is 6 potential internal validity threats that show up in these one-group pretest, post-test designs. Third thing is 3 potential internal validity threats that happen in any experiment. So even if you don't use a one-group pre-test, post-test design, these can show up. And then the fourth is a short discussion about, with so many threats, really are experiments still useful? Do we still want to use them? Of course, the answers are going to be yes, but we'll talk about why. So first, the really bad experiment. So in red here, I highlight the overall form of the one group pre-test, post-test design. It's where you have your participants, you don't assign them to any groups, you just have them in the same group. You do a pre-test, then some sort of treatment, and then post-test. So 2 examples of these, B and C, you see you have campers, you measure rowdy behavior, you reduce sugar, and then you measure rowdy behavior. Or another, depressed women, measure depression, cognitive therapy, and then measure depression again. You can see what they're trying to understand is if you reduce sugar, does it reduce rowdy behavior? Or if you give cognitive therapy, is it going to reduce depression? So let's say these are the results we got. So rowdy behavior did go down, and so did depression. So what does that mean? Does it mean that our treatment worked? Maybe. Or it could just be rowdy behavior goes down towards the end of the week. Maybe the kids come in, they're just really excited about it, but by the end of the week they're tired, they've done a lot, and so they're just not as rowdy. Or they've learned the rules and they understand that the rules are helping them to have more fun, so they're just less rowdy. Also with the depression score, it may be that just being aware. Now these people come in, they find out that they might have some depression, and so maybe it's not the cognitive therapy that's helping them decrease depression, maybe it's other things. Maybe it's just over time these people got better. Time has a tendency to do that. So all of these things could play a role in why those decreased. We're going to give each of those a name. So these threats to validity are particularly found in the one group pre-test, post-test designs. So maturation, history, regression, attrition, testing, and instrumentation. We're going to talk about each of those. First one, maturation threats to internal validity. So what's a maturation threat? It's a change in behavior that emerges spontaneously over time. It's just something that happens. So, for example, if you're looking at kids in school, you may have an intervention to see if you can help them read better. Well, it turns out kids in school are learning how to read better no matter what. It's just part of their growth. It's part of their maturation, and so it just happens, whether or not your intervention actually does something. So to help with maturation threats, we actually can do a 2-group pre-test, post-test design. Here's an example of that with the depression score. So if this was our results, so pre-therapy, both groups were here. After some time, the no therapy group is here. After the therapy group received therapy, they're here. This would suggest some of this is just maturation. It's just what happens. People just tend to get better over time. So that would be the green line. This orange line, it's a little bit more, it's a stronger slope, which suggests that there's probably something a little bit more than just maturation. So some of this is maturation, but some of it may actually be therapy. So the two-group design actually helps us answer that question. Is it just maturation? The next one is history. So what is a history threat? It's basically when some external or, to use the name, historical event affects most members of the treatment group at the same time as a treatment. So it's unclear whether the change in the outcome was actually a result of the treatment itself. So for example, suppose you were studying the effects of meditation on stress levels among college students. And while you're conducting the study, a violent event occurred on the college campus at which you were collecting your data. The meditation group did not show significant decreases in stress levels as expected. But was that because the treatment wasn't effective, or was it because the violence on campus raised people's stress levels, which makes it look like it's not effective? Another example is here on the screen. So if you're looking at how much energy is being used, and you have a group that has no campaign and a group that has a Go Green campaign in October, if this was the result, this would say that the Green campaign didn't do anything. All dorms just reduced power. Probably because it's getting colder, we're using less AC, things like that. If this were to happen though, so the Go Green actually ends up lower than the No campaign, this suggests that maybe it is actually helping in addition to what is already happening just due to weather. So how do we actually prevent history threats? So again, one way is to actually look at a two-group design instead of a one-group design. Sometimes, though, the things just happen. So, for example, if we go back to that violence on campus idea, if we were collecting data on one campus and that was the treatment group, and on another campus we were doing the control group, then if the violence was just on one of those campuses, then we wouldn't be able to tell the difference. We would still have a history threat. But if both the treatment and control group are both at the same campus, and something happens like that, then the two groups can actually still help us distinguish, because both groups would be affected roughly equally by that event. Another one, regression threats to internal validity. So what's a regression threat? It's extremely low or extremely high performance at time 1 is likely to be less extreme at time 2. It's a statistical phenomenon that we see a lot. If someone is performing particularly good at one point, they're generally not going to do as good the next time. So, for example, there's a curse that's called the curse of the front cover. And it's basically when a sports athlete gets onto a front cover of a magazine, they tend to do worse after that. And so people have been like, oh, the pressure gets to them. But it actually turns out it has a lot more to do with regression than anything else. And that basically is because the reason why they get on the front cover in the first place is because they are doing particularly good during that stretch. So just due to chance, at some point they're going to come back down to roughly normal for them. And so often that happens after they get all this hype and they get on in the magazines and stuff like that, and then they go back down to normal. Not necessarily because of anything to do with pressure, it just happens. So again, to prevent regression threats causing problems to your experiment, you actually can, again, do two groups. You want both groups to start around the same place. You don't want one group to be really high in depression and another group to be really low. You want them to be roughly around the same place, and then you see what happens after therapy for the therapy group and just over time for the no therapy group. So really high individuals, like here, both groups have really high depression. The no therapy group improves just due to regression. That just happens. Therapy group improves a little bit more. And so the difference here is how much that therapy group actually adds to it. So regression is just something that happens. Really high or really low performers generally do closer to the average the next time. Another thing, attrition. Attrition is when someone is missing at post-test, essentially. So you have fewer participants at post-test than pre-test. When that happens, it depends on where the individuals were from at the beginning. So consider this example right here. We have individuals that are at the top, and then they're missing at time 2. So this group, if we don't account for the fact that these two were very high, the means will change just because these two are missing. Everyone else did exactly the same, but the mean is lower. On the other hand, if people are more in the middle that are missing, more average, then it may not actually affect the results all that much. So you have to account for who is missing. And sometimes the missingness happens because maybe your treatment is not that fun. Maybe they have to take medicine every day, or they have to undergo a certain type of therapy that's not very pleasant. If that's the case, then you might have people leave for that reason, and that can really make it so you don't have internal validity for that study. Another one's testing. So what's a testing threat? It's a type of order effect in which there's a change in participants as a result of experiencing the outcome, the test, more than once. So if the test you're giving is one that people pick up on pretty quickly and they can learn from, then sometimes just having a pre-test and then having a post-test, they'll do better just on post-test because they learned the first time. When this is the case, again, having a comparison group, some sort of treatment group or some sort of control group that doesn't have the treatment, that can tell you, is there a difference? So maybe this group, they do, so the comparison group does improve just the testing effect, but the treatment group improves more. So again, you keep seeing this over and over again. How do we prevent a lot of these things? We do two groups. All right, the last one that's specific to this one group is instrumentation. This threat occurs when a measuring instrument changes over time. So over time, depression instruments have changed. We have different measures of depression. So if your study is kind of long-term, maybe over several years, this can happen sometimes where the way that you're measuring depression could change over time. This also happens with technology. So our first measure, maybe we're taking heart rate, and maybe the heart rate's okay the first time, but we do it a different way the next time because we know it's a better way of measuring heart rate. The differences between the two time points could be just due to instrumentation. To prevent an instrumentation threat, for one thing, you can just make sure that the instruments are the same from pre-test to post-test. So don't allow things to change as much as possible. You also can have the time points not as far apart. But if those things are necessary, it can be really good to make sure your instruments will last and that they will work from year to year. One confusing thing that can happen is instrumentation versus testing. So instrumentation threat, it's the instrument that's measuring it that changes. The testing threat is where the participant actually changes. They figure out the test. So they both have to do with measuring, but testing has to do with the individual figuring it out. Instrumentation is with the measurement actually changing. All right, so there's some combined threats as well. So you can have selection history threat. So an outside event or factor systematically affects participants at one level of the IB. So if you have two groups, the selection history threat means that some event only affected one of the groups, either the control or the treatment group. So for whatever reason, it affected those people and not the others. The selection attrition threat we talked about a little bit. It's where one experimental group, so either treatment or control, actually experience attrition more than the others. This also happens when you bring somebody in. So you bring in participants in and you recruited them by saying you have this new treatment, it can help with a bunch of stuff. If the participant realizes that they're in the control group, they're not getting the beneficial treatment that they felt like they were promised, they may not want to participate any longer, and so they may leave. So that would be an example of the selection attrition threat, where something about the group actually makes them less likely to participate later on. All right, so those all apply particularly to the one group pre-test, post-test design. The selection history threat, the selection attrition threat, those apply more generally. And so do these three. So you have observer bias, you have demand characteristics, and placebo effects. So when it comes to observer bias, that's a bias caused by researchers' expectations actually influencing how they interpret the results. So you may, as a researcher, think a certain thing's going to happen, and so when you get the results, you're going to look for anything that meets that interpretation. That's called observer bias. Demand characteristics, that occurs when participants figure out what a research study is about and change their behavior in the expected direction. So you may be like, so I'm in this study and I realize they're wondering about my charitable behavior. And so maybe I'm going to try to be more charitable at the next measurement. So that would be demand characteristics. That can happen in any study. Often we try to control for these. So we do what's called a double-blind study, where the researcher and participants don't know what group they're in. The mass study, these are ways of just making it so these biases that can happen both from the researcher and the participant are less likely to happen. So the difference between these two, the double-blind study and the mass study, double-blind is where both participants and researchers don't know what group they're in. The masked study is, you can think of it as just a single-blind design, and that's where participants know which group they're in, but observers don't. So the researchers' expectations won't influence it, but still possibly the participants could have this demand characteristics. They may figure things out and change their behavior. So the last threat we're going to talk about is the placebo effect. So sometimes by just giving some sort of treatment, even if the treatment doesn't work at all, there can still be an effect. This is what's called the placebo effect. Placebos, it happens whether or not something's actually working. So for example, participants are told they're receiving a new therapy, pill, or injection. But in fact, it's actually missing the active ingredient. So all they're getting is either a sugar pill, a fake therapy, or just a poke. And they're told that they're actually getting it. The placebo effect happens when the participants actually improve, even though they never got anything. They got a sugar pill or a fake therapy or just a poke that felt like an injection. So we got to design our study to rule those things out. Often that can happen by having what's called a placebo group. So in that group, you give them something that looks like therapy or looks like the treatment, but is actually missing what is supposed to work in that treatment. So for one example, you have the true therapy and a placebo therapy, and you're looking at change in symptoms over time. Often people will do a 3-group design. They'll have the real therapy, the placebo, and then no therapy, and see what happens. And this is a common pattern where true therapy may be the most effective, while the placebo is somewhere in the middle of the true therapy and no therapy. So with so many threats, are experiments still useful? So we're looking at a number of these threats here, 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 and here. So on the slides, you can look through all those. Overall, experiments are still the gold standard. There are potential problems. However, a lot of them have solutions. There's things we can do to make these essentially go away, or at least be able to measure them. So just because there are threats to validity, it doesn't mean that experiments are not useful. In fact, it's really good to be aware of these things so that when you're planning your experiment, you can take these into account. So for your proposal, if you're doing an experiment, you might want to consider, should I do a double-blind study? Is that possible? If it's not, should I do a mass study? Be thinking through how you can counteract some of these, or at least account for it in the design. All right, so now what happens if we do an experiment and there are no differences? So we put them in different groups and there's no difference between any of them. So when that happens, there's a number of reasons why that could have happened. First, there might not be enough between groups difference. Maybe the difference is really small. So maybe we need a bigger sample in order to find that difference. Another reason, maybe within groups, variability obscured the group differences. So maybe there's just so much movement within the groups that it's really hard to tell the difference between them. Another reason, maybe there really is no difference. Maybe the treatment really doesn't work. Ultimately, real null effects can be hard to find because it could be any of these in any null situation. So here are 3 examples of null effects. First is happiness, given no cash, some cash, a lot of cash. What researchers may have been expecting is this would be low, this would be high, and this would be the highest. But they're not finding a whole lot of differences here. Another one, reading score. Online reading games maybe a little bit helps, but not much. Or low anxiety, medium, and high anxiety on logical reasoning score. These things happen all the time. And it's really important to understand what they could possibly mean. They may not be the most exciting. Journals don't always publish these very often, and the media don't usually talk about them a whole lot. But there's reasons that they could exist, and they're still important findings. So the idea that there might not be enough between groups differences, that could be because the manipulation was just too weak. So maybe if you're looking at the effect of fear on charitable giving, maybe you didn't make them scared enough. Maybe they just didn't feel scared. Maybe your measures aren't sensitive enough, so maybe your measure of charitable giving isn't very good. There can also be ceiling and floor effects. We're going to talk about that in the next slide a little bit. Overall, what we can do is we can have manipulation checks to help us know if there's a weak manipulation or if there's ceilings and floors. And then we're going to talk about this last thing, design, confound, acting in reverse. So the ceiling and floor effects, it's basically where a ceiling effect happens when the questions are too easy. So basically everyone's getting them right. So you can think of that as a really easy exam. It doesn't really measure very well where people are at because everyone is right at the top. The floor effect is the exact opposite. It's where questions are just too hard. Everyone gets them wrong. So it could be an exam that's just so hard that you don't get anything right. It doesn't really tell you what you do know. It just told you everything about what you don't know. So the ceilings and floor effects can happen in both the IV and DV. And when it happens in the IV, it can be the result of a problematic manipulation. For example, in the money and mood study that I showed where there's null effects, the 3 levels of the IV were all really low amounts. They were none, 25 cents, or $1. May not be enough to actually change moods. So that could be a problem with our IV there. So ceilings and floors can also happen in DVs as well. So if you look at this graph, we're trying to look at the difference between control and reading games. And if there's a ceiling effect, it's going to be really hard to tell the differences between these because all of them are going to be really high. This will also be true if we do questions that are too hard, so everyone's getting them wrong. We won't be able to see the differences very well. So one way to understand about your manipulation, did your IV, is it good, is doing a manipulation check. So you may do a manipulation check about anxiety. So a low anxiety group, a medium, and high. And if this is the case, how anxious are you? Our manipulation didn't work. The low anxiety group's actually slightly higher than the others. For B though, this is where it did work. The low anxiety group is the lowest, the medium is somewhere in between, and high is the highest. So you want to measure these things. So if we're trying to induce anxiety in individuals, we want to measure, did they actually feel that anxiety? So although confounds usually threaten internal validity, they can also apply to null effects. So consider this example. In the GRE study, perhaps that test prep group was also under additional pressure to perform well on the GRE. As a result, they were actually receiving test prep and pressure, while the no test prep group didn't have test prep or pressure. So the added pressure that was applied could be considered a confound. It could have actually hurt the test prep group. It could work against them by lowering their scores. So they learned in the test prep, but they also felt a lot of pressure, and so it actually reduced their scores. So this is one place that we would also want to measure that. We would want to measure what kind of pressure do you feel? Do you feel anxious about taking the exam? And those things would help us understand if there are other confounds acting possibly in reverse where it's actually hurting our study. All right, another thing, perhaps the within groups variability obscured the group differences. Here, ideas such as measurement error, there's individual differences, and situation noise. Each of these can impact how much variability happened within groups. So measurement error is basically your measure is not that great, so there's a lot of noise in the measure itself. So it's like trying to measure someone's height using forearm distances instead of inches. So someone might be like 5 forearms tall, but maybe someone else has different size forearms, and so someone's going to be maybe the same height but have a different measure. So a solution for that is actually using reliable, precise measures. So don't use a forearm, use a measuring stick. You also can measure more instances. That helps you see how much variability happened over time just in the measure. When it comes to individual differences, this is just where everyone has their own overall naturally occurring differences. So Michael's a really happy person. Candace over here is a less happy person. So even though Michael didn't get any money, he's just more happy on average. Candace got money, but still is just not that happy. So this study, we wouldn't be able to tell a difference between the two groups because they look basically the same because of how much naturally occurring differences there are in happiness. So a solution to this is actually doing a within groups design. So we have Michael in the no money group and Michael in the $1 group. So we can see, oh, it actually went up. So he's already naturally really happy, but it looks like he got even happier when he was given $1. Same with Candace. She's generally lower, but actually goes up a little bit with $1. So that's one way of doing this. Another is to add more participants. Always when you add more participants, that helps you get more precise estimates. So it's one way that you can help account for individual differences better. Last thing to consider with this is situation noise. It's any kind of external distraction that could cause variability within groups that could obscure the between groups differences. So this can be minimized by controlling the surroundings of an experiment. So for example, you might bring people in, and what if you had just a poster that had something political on it? So it may affect some people differently than others, and so it's going to cause some noise in how they respond to something. Because it may be a turnoff, it may get them excited about politics, whatever it does, it could change how someone responds. So it can actually cause more variability. Overall, these solutions are tied to this idea of power, statistical power. As a reminder, power is the likelihood that a study will yield a statistically significant result when the IV really has an effect. So the effect really is out there. Studies with a lot of power are more likely to detect true differences. So consider this example right here. The guy comes in with a candle and has low power. He can see the skateboard, but that's it. There's other things that may be in the room, but he won't be able to see it. But if he came back with more power, with a really strong flashlight, he's going to see the skateboard, but he's also going to see this tiny key. So high-powered studies can see even smaller stuff, things that are harder to see, where low-powered studies can only see the big stuff. So here's a review again of all these reasons that a null result could happen. Keep these in mind. This table's in the book. Review this. As you're preparing your final draft of your proposal, when you talk about possible limitations, these are things to keep in mind. So one last thing to keep in mind is null effects may be published less often. They can be just as interesting as experiments that show group differences, but overall, because there's some level of we can't make a conclusive decision, it makes it so these are less popular. People like them less. So they are still very important, and hopefully science is changing, but right now they're still less common to be reported. And that is it for chapter 11. Reach out with any questions you have. All this stuff can apply to your proposal, and so find ways to integrate it in the proper locations, especially in the methods section, and reach out if you have questions.